Hello, everyone, and welcome to the Biophotonics Discovery Podcast. Whether you're a seasoned researcher, a student just starting out, or you just love a good story about how light is used to solve big problems, this podcast is for you. We're making the discoveries in biophotonics accessible one episode at a time.
Hello, everyone. My name is Travis Sawyer. I'm an assistant professor of optical sciences at the University of Arizona, and I'm an associate editor for Biophotonics Discovery, a new journal by SPIE. As part of outreach for the journal, we're doing a series of discussions and interviews with leaders in our field to learn more about their careers, gain insight from their wisdom, and understand what they see as some of the most exciting research topics in the near future. As part of that effort, it is my great pleasure to have Dr. Laura Marcu with me here today in Arizona. As a formal introduction, Dr. Marcu is a professor of biomedical engineering at the University of California, Davis, and the director of the National Center for Interventional Biophotonics Technologies. Laura, thank you so much for being here with me today. So to start things off, I think the audience always loves to hear a little bit about your background and how your career evolved. And so could you tell us a little bit about your early life and maybe where you grew up?
I was born in Romania, and I went to school in Polytechnic Institute in Bucharest when it comes to my early background, which connects to biophotonics. And I moved to United States in early 90s. And this is where I did my PhD at University of Southern California in biomedical engineering.
That's awesome. And so did you encounter any challenges doing that transition over from Europe to the United States in the early 90s? Or what was your kind of impression of that?
Well, it was an interesting experience because I moved here after the collapse of the communist regime. And I moved directly to California, where I knew only from movies. But I very much enjoy the school and approach to education, which was more applied, and in terms of looking at math and physics in a way that you can connect it with the real world applications.
Interesting.
And that was a very interesting way of looking at or resolving problems.
Interesting. Yeah, I imagine it must have been a very eye-opening experience to kind of transition and culturally as well. That's awesome. And so I think you had mentioned a little bit that your background was started off in biophotonics. And so could you kind of give a little bit of a introduction how you got introduced into this field and maybe what about it attracted you to continue to contribute?
Yeah, to some degree, my path into biophotonics was a bit of serendipity. I've always been drawn by physics and math. And I recall as a kid, I liked playing with flashlights. And I even built my own when I realized that I can put together a battery, two wires, and a bulb. I use it to read after bedtime.
Interesting.
Hiding under the blanket so my parents wouldn't notice. Then in high school, this was again in communist Romania, my school shifted its curriculum from our general education to math and physics. And that pushed me further in that direction. So then originally I thought that I would like to go to medical school. But organic chemistry was not my cup of tea. And then I decided to choose mechanical engineering, which is a very big department and has a kind of sub-departments. And one of them was fine mechanics and precision mechanics. When one of the emphasis was in optics instrument and instruments for measurement and control. And that is where I was first exposed to optics and optomechanical design. And as I mentioned earlier, after I graduated, I actually work in a research institute designing spectrophotometers. And then I moved to United States, and where I started and joined the biomedical engineering program at University of Southern California. And there it happened that my advisor was collaborating with the Laser Center, Cedars-Sinai Medical Center in Los Angeles. And this was practically in the 90s, mid-90s. And this is where I was exposed first to biophotonics. At that time, it was not called biophotonics, it was more biomedical optics, or there were some other terms. And this laser center, laser center, Cedars-Sinai, was led by Warren Grunfest, who was a surgeon by training. And that lab or center was pioneering several biophotonic techniques from the very early stages of near-infrared spectroscopy, of fluorescence spectroscopy, Raman spectroscopy, photodynamic therapy. Then they were testing new endoscopic systems in large animal models. So it was a very eye-opening, and that space where on a daily basis almost you see engineers, scientists, students, postdocs interacting with medical community and MDs. And I think that is what kind of shaped my thinking and my career, was that interface and the exposure to, at one hand, engineering and medical problems, and also by leveraging on my early background in optics. That probably was a important factor in how my career evolved in a longer term.
Thank you. That was wonderful. I think it sounds like you've been an entrepreneur since the beginning with your flashlight. And I also think that your opinions of organic chemistry are probably shared among many people. But yeah, that's, I think, a wonderful kind of story to hear, because I feel like many people who do end up in the field of optics sort of wander their way there, but the exposure to the applications, the interdisciplinary collaborations, I think that's something that I've found is always common in the field, is that you really do have to work with other people. And for us in biophotonics, the clinical side is really, really important. So now jumping kind of to the present. So right now, I know that you have a wonderfully productive lab and you have several well-defined research directions. But for maybe the early career audience members that might be listening, could you talk a little bit about how these research directions that you now have evolved from when you maybe first started off as a faculty member and early career researcher, since those are not always kind of linear pathways?
Okay. When I finished my PhD, this was now in late 90s, I actually had no intention to pursue an academic career. And I was practically looking for a job.
Mm-hmm.
And this is where Warren Grufest, I just mentioned earlier, offered me a postdoctoral position in Laser Center, so I could continue some of the work I started as part of my PhD thesis. And interestingly enough, not long after I joined, he asked everyone in the center to write grants. And he asked me to write another one.
Oh, wow. Okay.
Yes, based on my PhD thesis, which was more related to fluorescence lifetime spectroscopy as applied to atherosclerosis. And initially, I thought that was wildly unrealistic, and this. And actually, so did everyone around me. Against all the expectation, I got a very high score. It was
Wow.
about like a 6 or 7 percentile,
Amazing.
which was very, very interesting. So suddenly, here I am after 2 or 3 years of graduating from of a PhD. I have a major NIH grant that kind of throw me in a pool, so I had to swim.
Yeah.
So from there, my research direction have started to evolve
Interesting.
and to build my own lab, my own group, and here we are.
No, that's great. I think that's amazing, starting off with such strong early success. So I think you've mentioned Warren a few times now, and
Yeah.
I imagine he's probably one mentor that you've had in the past. But do you have any other mentors through your career that you'd like to maybe mention and what their impact was on you?
I have many people who inspire me along this way. Um, so I've been fortunate to actually meet along my career. So I would say even now I have mentors. Actually, not necessarily mentor in a kind of conventional way that you meet regularly, but people who inspire me, people who I can consult with and talk with. But one of that is actually shaped a lot of my thinking, and was Martin Anderson.
Mm.
So Martin Anderson is now a professor emeritus of electrical and computer engineering at University of Southern California. And he's not widely known in biophotonics because his background was in quantum electronics, lasers, and plasma physics. And the way I started to interact with him is because later in his career, he was interested in applying the plasma physics or pulse power to biophysical and medical problems. Martin was a complex individual. Actually, he's retired now. But someone who can place science in the context of history and philosophy, and even to the popular culture. Actually, he was the scientific consultant for a science fiction movie, Real Genius.
Oh, okay.
Yes. And from him, I learned the value of thinking outside the box. Also, that it's important to surround yourself with people who can challenge you, and also to aim higher than you think that is possible. And he was the one that actually encouraged me to pursue an academic career at the point where I was not thinking that this is possible because was not my plan, or it was not something that I even dreamed before. And also guide my initial step into this career path,
That's awesome. That sounds very
academic
inspirational.
path. Yes.
Well, I think the field has benefited greatly from it.
Yes.
Um, Thank you. And so now, of course, you are a mentor to many, and so I'm wondering if maybe you could tell me a little bit about what is your philosophy to mentoring others and having them in your team and that type of thing.
Yes, that's a very, very important question. If I'm talking now about early career faculty, I would say to learn how to zoom out and to learn how to look at the bigger picture and start developing your own thinking and vision and approach, learn how to connect the dots. So the ability to zoom out and zoom in, I think is very, very important. Another aspect when it comes to starting a career, an academic career, I think is how to learn how to build a team and to manage resources, and of course, managing people. Especially if you're, let's say, on biophotonics or biomedical engineering, which is highly interdisciplinary field, and you work with individuals who are coming from a variety of backgrounds, scientific backgrounds. Is where you have to find a common denominator and to have a cohesive team where everyone um, um, are, I want to say, aligned, but they coupled the thinking and together they achieve and work cohesively on a project.
Interesting. It almost sounds like an engineering at the team scale where you want to have the
Yes,
different parts produce
yes,
a whole which is better than the sum of the parts.
yes.
That's great advice. Thank you. And so I did want to ask a little bit about some of your contributions beyond research. And so, for example, I know that you're involved with a few leadership activities, such as with SPIE, and then also at your institution, like building the National Center for Interventional Biophotonics Technologies. And so I was just curious to hear a little bit about what got you interested in pursuing these kind of larger scale leadership things, and how do you envision that kind of being part of your legacy?
So leadership and stepping up to contribute to the broader community. So my first experience with leadership was after I joined UC Davis. Shortly after, I probably because of my experience with clinical translation, I was invited to join the Cancer Center, and in particular to lead the or co-lead the biomedical technology program within the Cancer Center. And that was eye-opening to me because I learned at one end how important is to build a new program or to shape an existing program. Also, how to get people from different departments and colleges to work together on solving problems, and what kind of resources are needed in order to engage. And these are things that it's not something that you do as part of your own research lab. You want to put together and connect the dots now, not only in the science, but also to have people to buy in and to contribute to that more shared goal. And this is where was my first exposure to and understand what it takes to build a broader program and to impact a broader community.
Interesting. That's great. Yeah. And I feel like it's very important because you can make some really long lasting impacts that way.
I see.
So I think it's always interesting to have a little bit more of a personal aspect to these discussions. And so I'd love to hear a little bit more about like, what do you do outside of your, job as a researcher, a mentor, a teacher, all of those things?
Well, so I like travel. I like to learn about places, culture, people, traditions. I like going to concerts. I like classical music.
Oh, okay.
I like tennis,
Okay.
skiing, and fencing.
Oh, fencing.
So
Interesting.
actually, when I moved to UC Davis, was about 20 years ago, I thought, what else should I do here? So I took some fencing lessons,
Interesting.
which was a very interesting experience because at one end, it's not just about physical skills. It's also about strategy, quick thinking, and focus.
Yeah.
So these are things that you don't, aspects that you don't really think about initially, but you have to put these two together in order to be able to fence.
Yeah, that's really interesting.
Yes, so there are many things that I wish I can have more time for.
As do we all. But that's awesome. I think that's a very, very unique hobby and thing that kind of complements probably what you do in work by developing those skills in a totally different scenario.
Between us, I didn't fence for a while.
Oh, that once a fencer, always a
Yes.
fencer. Yeah, that's really interesting. Thank you. So getting a little bit into the research, I'm aware that you've pioneered some amazing technologies using fluorescence lifetime imaging or FLIM for guiding surgical interventions or cardiovascular implications. And so first, just in the last, 15, 10 years, what were some key advancements that led to these technological discoveries and developments in your lab?
One is the fact that I started with I go back in time, and I start practically have a strong background which came from my initial work in fluorescence lifetime imaging as part of my PhD thesis. But that over time branch out to applying this technology in several applications, but also in parallel was an advancement in the instrumentation, the technology available on the market in order to be able or advance in the science that allow to refine this technology. So practically on one end, it branched out to different applications. And at the other end was the idea of how you can actually make this technology or techniques more um, practical at one end, if we're talking about the clinical translation, but also more performant technologically. So that was the advancement and the availability of new lasers, new digitizers, and new discoveries allows us to evolve in parallel in terms of building new instruments, more performant, more suitable for a clinical setting. At the other end, to branch out again to different applications, and also to think about different multimodal systems, not just having one dimension, which is coming from fluorescence lifetime, but adding to that different modalities. So we started initially with ultrasound backscatter microscopy, and then with photoacoustics, and then OCT, and some other techniques. So this practically um, provided a new dimension to the research and applications, and complemented what I started with, which the base was practically fluorescence lifetime spectroscopy, and then that evolved in imaging.
Awesome.
So so it's like a tree that grows over time and,
Yeah.
and have different branches.
No, it's great to have the kind of diverse the pathways in which you can kind of go about the research.
Yes.
So I know that right now you're doing some work in the brain for tumor margin identification. Is that true?
Yes, it's for identifying or it's image-guided procedures. Yeah.
Image-guided surgery. Could you talk a little bit about where are you at right now in terms of the kind of pathway of translation? Are you doing clinical testing? Are you at the point of trials? I'm just curious to learn more.
Yes, I'm very excited now after all these years. We're actually doing more consistent and systematic studies in patients
Oh, okay.
using this technique, where not only we collect data and we analyze it offline, we're actually augmenting this information in real time, not on the surgical field of view, but also we can also augment this data on the preoperative MRI that is conventionally used to guide the procedure. So this is very exciting because now we can fully integrate fluorescence lifetime imaging into neurosurgical pathway and clinical management.
That's amazing. Yeah, very
Tumors.
impactful, especially the idea of kind of merging it with the preoperative MRI to
Yeah.
give kind of an enhanced view. And so in this method, is this something that you need to kind of remove the skull to take the data, or can you do it through the skull with like small holes or anything like that? Like how does it kind of work in terms of the application?
So we apply it currently in two ways when it comes to brain. One is during craniotomy. This means that the tumor is already exposed, and the idea is to uh, remove the infiltrative edges as much as possible. And that's one. So practically have direct access to tumors. The second is using a biopsy needle. So where we integrate fiber optic on existing biopsy probes, which are used for sampling the tumor, and we can measure along the needle track the optical properties or fluorescence properties of tissues or the advances through, with the idea of biopsying the actual tumor, not something else, so to increase the chances to have a biopsy or diagnostic sample.
Interesting. It's great that you have those kind of two methods, since, of course, the skull can be difficult to get through.
Yes.
In the scope of brain cancer, is there a specific type of brain cancer, like glioblastoma, that you're looking at, or are you just looking at generally any brain cancer that might need surgical intervention?
So we're looking of different type of, well, the brain tumors are it's called adult diffuse gliomas, and there are different grades or different type of tumors within this larger category. Are let's say astrocytomas or oligodendrogliomas and GBM or glioblastomas, which are the most aggressive type of tumors. And each of these subtype will have different grades within them. And right now, we do try to do this stratification and to understand which one, what are the signatures for each of these type of tumors, because some of the, say, oligodendrogliomas or astrocytomas may have a different way of being treated rather than a GBM.
Right.
And it would be important to see whether we can distinguish rapidly between this different type of tumors, because that may influence the way the patient is treated.
That's great. So almost
Or
like,
maybe surgery is approached.
yeah, so sort of like phenotyping the tumor and
Yes.
helping inform the clinical approach. That's
Yeah.
awesome. And so then also in terms of cardiovascular applications, you mentioned that was one of your first kind of exposures. And so
Yes.
are you still pursuing that as a research area?
Yeah, that was my baby that I started with it as part of my PhD thesis. And that evolved over time, and probably is the most challenging way of implementing fluorescence lifetime spectroscopy or imaging now, because it's you have to go in the very narrow coronary arteries. You have to build new catheters, and you have to deal with very dynamic environment, and also blood that has to be removed, and you have to perform these experiments very, very fast. So it took a long time to bring a point spectroscopy technique on a benchtop, looking at samples, to actually be able to conduct this in a pullback at very high speed in a matter of a couple of seconds to scan a coronary artery. And we perform studies on a benchtop, on animals, in a large animal like pigs, in vivo. And now, finally, we're at the stage where we apply for an IDE from FDA, and we hope in the next couple of months to get the approval so we can start the first studies in patients and enroll the patients into this study.
That's
So
incredible.
It's very exciting, yes, indeed.
Well, very exciting indeed. I think definitely be looking forward to the next few months. Then good luck with getting the IDE and getting to move forward.
Thank you.
So moving on to some more kind of general advice and that type of thing. You're someone who manages many responsibilities, which I think inevitably does happen as people progress in their careers. So I'm curious, do you have to make compromises in things that you undertake, the things that you agree to contribute to, and what kind of goes into that decision-making process of what you decide to take on or not?
That's a good question. I wish I can be very good at this, but I'm still tempted to some degree to explore new pathways. But of course, at some point, you have to be selective, and you probably have to ask yourself: is this something that aligns of the current program and goals? Is this something meaningful in a long term? And do I have the time to do it? So, if the answer is no to one of these questions, and I might have the second thought whether to take new things on. But I'm always learning from new experiences, from new collaborations. I think more my whole career was based on being able to establish new collaborations and learning more about problems that the medical community will have.
Interesting. Yeah, so it is a difficult decision then. Lots of factors, but you don't want to leave good opportunities that might come up either.
Yes, it's always something to learn from.
Definitely. Awesome. So, for new students or early career audience members who are interested in biophotonics, do you have advice or thoughts on how they can best position themselves to enter the field and then make contributions in their career?
So my biggest advice is to first build a strong scientific foundation, and that let your scientific contributions speak for themselves. And from there, leadership opportunities will come naturally once you have been build this strong foundation. This doesn't mean that you cannot engage with the community and volunteer, go to meetings, review papers, serve on different roles. So small roles always lead to something bigger.
Right.
And also probably seek mentors that are already doing a leadership role and learn from them what is going on behind the scenes and how they actually be able to implement and lead. So there are different ways of leading things, leading from behind and leading on a stage. And also you have to be willing to take small roles, and then from that things will evolve again. And working with people, understanding their problems, but I think importantly is to perceive that as a service that you do, and not necessarily that's something that you must do. And to really believe that your contribution and service is actually worthwhile.
That's great advice. Yeah, I think service is something that I think can be very rewarding, but you have to feel like you want to do it.
Yes.
And then you get a lot out of it. And so now looking forward to the next near future, I would say, first question is, what are you most excited about in the next, we'll say, 10 years of biophotonics? And then also, where do you see yourself fitting into that future in the next 5 or 10 years? So what are your plans?
So I think I'm excited by many things. I think this area of biophotonics or space of biophotonics has reached more maturity right now, and I'm very excited about the role that the computational methods and AI can actually play in a near future, but also in a longer term. I think AI and can play a role not only on analyzing the data and extracting information from and understanding the relationship between optical signals and biology, but also can help on designing different class of instruments. So it can influence the design of new optical systems. Another aspect that I think will play a role in the future is integrated photonics. And integrated photonics will enable, um, I think, developing a new generation of more compact devices and more deployable in different environments, of course, in challenging clinical environments. And this is one of the goal of our National Center for Interventional Biophotonic Technologies and now at UC Davis. And I think merging or working at the nexus or intersection of the current advances and understanding of light tissue interaction and with the ability of building new biophotonic systems and technology based again on integrated photonics, coupled with AI, I think can lead to a different generation of devices and applications.
Very exciting. That sounds like an amazing future that we have ahead of us. And so the very last question for today is, what do you see as maybe the biggest challenges in accomplishing those things that you just laid out? So the biggest challenges that our field might face in the next 10 years.
The biggest challenges, it's always challenges, depending on if you look at the challenges in a constructive way, as something that will move you from where you are to a different stage. And so one will be the resources which are be available from the funding, which we hope will continue to support our research, to people, which I think are very, very important, probably most important, to have a new generation of trainees that are passionate and interested on taking on this role. So creating this new workforce, not just in academia, but also in industry, who has the understanding from theory to engineering, from physics to engineering to implementation. I think that is a challenge, but also an opportunity. So how we train this new generation is very, very important. And we have to look at it, put it in the perspective of overall educational system, the willingness of the new generation to get into science, and this type of science in particular, and to these resources that will be available to support this work. And
excellent. Thank you so much for your time, Laura, and thank you everyone who's watching for your attention. Stay tuned for other interviews in this series. They'll be held by other members of the Biophotonics Discovery Editorial Board, and we'll be talking with other incredible leaders in our field. It'll be great to hear their insights and perspective like we did from Laura today. And if you haven't seen the other previous discussions we've had with Drs. Jennifer Barton and Anita Mahadavan Jensen, I highly recommend you check those out. So thank you again.